on the second to the last page, which is titled Linear Equations. So we're going to fill in these 4 boxes up top. We've got something called slope-intercept form. Anybody know it? No? All right, it's y equals, there we go, mx plus b. Has a great title, slope-intercept. Why? Because it gives you 2 things. It gives you the slope, gives you the intercept. All right? So slope is the variable m. Intercept is the variable b. That's where you put your 2 numbers, that y and the x stay in it. That's a great form for graphing, which we're going to see in just a second. There's another form called standard form, and the algebraic form looks like this, ax plus by equals c, and there's a number here, a number here, and a number here. If you, like 90% of the time when you're given an equation in standard form, you're going to want to change it to that form. And it's going to make your life a lot easier. Okay? There's also something called the slope formula. It starts with m equals. Anybody know it? Oh, that's the first box. We already did that one. This one starts with m equals. You take 2 points, an x1 and a y1, and a x2 and a y2. You plug them into y2 minus y1 over x2 minus x1. The 4th box, you don't see very often, but I'm going to show you today. It comes in handy and it's very useful. You're going to use a point, which comes in the form x1, y1, comma in there, and a slope, because it's called point slope formula. These 3 numbers, whatever they are going to be plugged into y minus the y1 equals m times the x minus the x1. And this one looks confusing because it has x twice, but the only number you plug in is for this x, the y you plug in for this y, and the m you plug in here. So that's where the 3 places you plug in with that one. Okay? All right, so let's talk about box number 55. The directions just say to graph each equation below. So this one's already in slope-intercept form. So we look in the m position. We have a slope of -4/3. We look in the b position, bless you, and we have a y-intercept of +2. So those are the 2 numbers that you need to graph, right? So you're going to start in the middle, what's called the origin. You're going to go along the y-axis, which is the vertical one. It's the darker line. You're going to go up to 1, 2 to +2. From that point, you have a slope of -4/3. So -4/3 go up or down? Down. Down. So you're going to count from here, 1, 2, 3, 4, and then you're going to count over 1, 2, 3, put a second point. How many points do you need to make a line? 2. So you're going to draw your line, put little arrows on the end of it, and there you go. Okay? So box number 56 comes in a form that we call standard form. So the best thing to do with it is to take it and to change it to slope-intercept form, meaning you want to get that y by itself. So you're going to subtract x from both sides of the equal sign. You're left with -2y equals -x plus 6. Or you could say 6 minus x, but I like to get it into the slope-intercept form, so I write my x term first. Then y is being multiplied by -2, so we divide everything by -2. These cancel, and now we can put it in slope-intercept form. We have a negative and a negative, so I'm just going to change it to positive. I'm going to pull the fraction out in front, because that's my slope, 1/2 x. And then -2 goes into 6, -3 times. Now we're in slope-intercept form. So our b, our y-intercept is at -3. Our slope is 1/2, and it's positive. So does it go up or down? This one's going to go up. So we need to start at -3 this time. So start at the origin, count down 1, 2, 3, put a point. From there, the slope is up 1/2. So you go up 1 over 2. You only need 2 points to make a line, but you can do another one if you want. Draw your line in, add some arrows. What do the arrows mean? Goes on forever in both directions, right? All right, box number 51, something's missing. What's missing? The x term. So this is the same as writing y equals 0x minus 4, right? There's no x term, so I'm going to plug in a slope of 0. If you have 0 slope, what's your line doing? It's not going up, it's not going down, it's just flat, okay? It's like you're in El Centro, right? You're just going straight, okay? So this is our B, our y-intercept is -4, and our slope is 0. So on the y-axis, we're going to go down to 1, 2, 3, 4, and it's flat, just like this. Anybody know the name of that line? It's called horizontal. Horizontal line. Okay, so when you go jump over to box number 58, instead of saying y equals -4, it says x equals -1. So what do you think this line is going to do? It's going to be the vertical line. So it's going to go up and down, and it's going to go through +1. So you come over here to +1 on the x-axis, and you draw your line straight up and down, and put your arrows on the ends. All right. Jumping down to box number 59, the directions say to find the slope of the line passing through the given points. So we're going to use the slope formula from up top. And if it helps you, you can label your points x1 and y1, x2 and y2, and then plug them into the slope formula. So if you have y2 minus y1, it's going to be 6 minus -9 over x2 minus x1, so 2 minus -4. And then we just want to simplify. When you have minus, minus, or subtracting a negative, you want to change it to plus, 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 plus. So 6 plus 9 is 15. 2 plus 4 is 6. And we've got our slope, but can we reduce it? Yes, these are both divisible by 3. So 3 goes into 15 5 times, and 3 goes into 6 twice. Right? Let's do one more instead of all 4 of those boxes. So box number 61, same thing. Label them x1 and y1, x2 and y2. Check out the formula up top if you still need it, but it's going to be -2 minus -2. That's a lot of negative signs. For the denominator, we're going to have -1 minus 3. So if all these negative signs mess you up, you can do it in your calculator, or you can use your little tricks. But hopefully these numbers are small enough it won't be too bad, right? So we've got minus a negative, so I'm going to change it to positive. And then here I'm going to say plus -3. So I have -2 plus 2, which is 0. And then I have -1 plus -3, which is -4. That means our slope is just 0, which was very much like number 51, right? So what kind of line is that going to be? Horizontal. What happens if you have the 0 in the denominator? It's going to be your vertical line, and it's technically what we call undefined. That's when you have the vertical. Any questions on box number 61? All right, jumping down to box number 63. The directions say for question 60 and 61, write the equation of the line in slope-intercept form using the given information. So we've got a point, let's call it x1 and y1. We've also got a slope of 1/4. Let's call it m. So if you go up top, you're going to look at the last box on the right, which says point slope form. And you're going to plug in the three numbers. You're going to plug in the y1. Well, so you're going to say y minus 1. Then the equation has an equal sign. Then it has, we want to plug in for m, so it's 1/4. Then there's a set of parentheses and x minus x1. So it's x minus -6. All right? So let's simplify here. We've got minus a negative, so let's change it to plus. And then we've got a set of parentheses and a fraction out front. So we're going to distribute here and here, right? So let's simplify that. Y minus 1 equals, and then 1/4 times x is 1/4 x. And 1/4 times 6 is 6/4. But we can reduce 6/4 to 3/2. And then we've still got this 1 over here. So we need to add 1, and we get y equals the 1/4 x. And if we have 3/2 plus 1, that gets us to 5/2. Okay? So if you have a point and a slope, just use the point slope formula. But in box number 64, you've got 2 points and no slope, but you know how to get the slope with the slope formula. So we're going to do that first. We're going to say that m is equal to the y2 minus the y1. So -7 minus 13 over the 2 minus -2. And we're going to simplify. So I'm going to change this to say plus -13. And we have a minus and negative, so I'm going to say plus plus. So -7 plus -13 is -20. And 2 plus 2 is 4. So 4 goes into -20, -5 times. So that's our slope. You can write it like that, or you can put a 1 in the denominator. So now we need to pick a point. Let's pick that first one. We'll use that as our x1 and our y1. We'll use this as our m, obviously. And we're going to use that point slope formula again. So we're going to say y minus our y1, which is 13, equals our slope m of -5, parentheses, x minus x1, which is -2. So easiest thing to do is change this to plus plus. Next easiest thing to do is distribute here and here. So we have y minus 13 equals -5x minus 10. And then the last step is to get the y by itself. So you add 13, and you get y equals -5x plus 3. All right. Last little box down at the bottom, give an example of a line that is parallel and perpendicular to this line right here. So we want to start with our x plus 3y equals 10. We're just going to subtract x from both sides. That leaves us with 3y equals -x plus 10. Then we just divide, because that's super small. Let me make it a little bigger. Sorry. There we go. Divide everything by 3. And we get y equals -1/3 x plus 10/3. So we need to get a line that's parallel to this, and we need a line that's perpendicular to this. Thank you. She's not here. And so lines that are parallel are going to have a special kind of slope. Who remembers? What kind of slope are you going to have to another line if you want them to be parallel? They're never going to touch or intersect.